All right, let me see. Let me try to start to catch up with you guys here. Ox equation here would be m squared minus 36, so you get m equals plus or minus 6, so you get y equals c1 e to the 6x plus c2. That's the best case. Right? When you have distinct roots, you're golden. Distinct real roots, especially. This guy, of course. So you get m equals
3.
Plus or minus 3i. Imaginary's got to come into play because you can't add two real numbers. So you add the square of a real number to a real number and get 0. It's impossible. Subtract 9, take square root, there's your I. Come popping out. Ouch. Sounds pretty painful. All right. So what's alpha? 0. Real part, 0. And beta is 3. I like it. So don't worry about the plus or minus here. You just worry about the beta. If you go through the derivation, you can see what they did with plus or minus. It's related to the identity rules for cosine and sine, negative inputs, positive outputs, and so forth. So what do you get? You get, so you have, yeah. So e to the alpha x, alpha is 0, e to the 0 is 1. So that piece is kind of, that multiplier piece is gone. C1 plus sine 3x plus C2 cosine 3x. And if you think about it, we did do one of these really early on in the semester. What was related directly to its second derivative, sine and cosine, right? With the plus. So what about, in number 3, I gave you a little hint on this guy. So its ox equation would be m cubed minus 1. So this will be m minus 1. So you get m equals 1, or m equals negative 1. Yeah, so it'll be plus or minus square root of 1 minus 4. So it'll be negative, so it'll be I rad 3 all over 2. So alpha here is negative 1/2, the real part. Beta is square root of 3 over 2. I like it. So then I get, from this guy I get a nice one. E to the x plus, I like e to the negative 1/2 x times C1 sine rad 3 over 2x plus C2 cosine rad 3 over 2x. Oh. Sine beta x, cosine beta x. And then the one that I'm sure was everybody's favorite. But the last number is 5. Why is that a good thing? The last number is 5. Why is that nice? Nobody remembers? So the ox equation would be m5, 5m4, 2, got it. M cubed minus 10m squared plus m plus 5 equals 0. There is no quintic formula, the quadratic formula. There's no. Cardano found one for cubic, and that's actually one of the first places where complex numbers popped out and freaked people out. I don't know if anybody's ever heard of that. Cardano found a quadratic equivalent for a cubic. All right, if you're interested, you can look that up. Cardano, he's a little crazy. He was involved in duels with other mathematicians and shit. Yeah, the history of math has some. It's more exciting than it seems like it would be. Hopefully everybody knows synthetic division, because it's the quickest way to long divide and shit. I don't want to long divide. So what are the factors of 5? They have to be, if this is going to factor like this, what numbers have to go down here? They have to be numbers that go into 5, because that's where 5 would come from. the product of all those last terms. So let me try to synthetically divide by 1. Let's try. 1, 5, negative 2, negative 10, 1, 5. Does that look familiar at all? All right, maybe it's worth showing you the full-blown ugliness. So everybody got what they want from these first three? So who knows, if I put that in the penalty box here is what I call it, if I put that there, what's the factor it's related to? Anybody remember? Anybody know synthetic division at all? Okay, so this is related to m minus 1. So I think it's probably useful to do this. Because, I mean, synthetic division is just so freaking useful. We don't have any factoring rules for this shit. So thank God synthetic division exists, and you guys are like, stop saying the word, just tell me what the shit is. So if I wanted to long divide by this, I'm going to do this once. Holy crap. Yeah. And real quick, by the way, if I asked you to long divide this, what would be the first number you put here? No. We don't put zeros up there. I love you guys. Do you remember how to long divide numbers? Shit, it's been too long. 41 goes into 339. You don't even think about that, do you? You think 4 goes into 33, don't you? If you remember, if you really reach back. You guys remember long division numbers? You're like, who is this guy? I don't care. Everything has a purpose for everything else. I would do an 8, because 8 times 4 is 32. So I'm trying to explain something that happens here. I look at the 4 into 33, and then of course I multiply 8 times 4 and 8 times 1. I get 8 times 40, 320, 328. Minus, I change the sign of the number, and I combine them and keep going. All right, so I don't do that. I do m into m to the 5th. Is m to the 4th. That times m is m to the 5th. That times negative 1 is negative m to the 4th. Change the signs. Just the same way we change the signs of that one. Okay. Shoop. Average of it, 6. Bring down the minus 2m cubed. This is the last step I'm doing. M into 6m4 is 6m cubed. 6m4 minus 6m cubed. Change the signs. 4m cubed. Bring down blah, 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 blah. Right? All right. So, what's the first few steps of this? This is like a matrix. What's one of the first uses of a matrix is to represent a system of equations, and then you can attack it in a much more systematic way. Are you guys remembering that part? So synthetic division is like the same idea. It takes all the bullshit variables. Look at all the shit that I keep writing. Why would I write this shit when it's going to die? I wrote this shit. It's dead. Who cares? I care about this shit. 5 and 1 is 6. I care about 1 and 6. I care about some of this nothing. So watch. Here's the idea. Why was this a 1 m to the 4th? Because this is a 1. Right? If that would have been a 2, I would have put a 2 there. So I bring the 1 down. 1 times 1 is 1. 5 and 1 is 6. 5 and 1 is 6. 1 times 6 is 6. Negative 2 and 6 is 4. Negative 2 and 6 is 4. And it's related to m minus 1, because one of the most annoying things here is you have to remember to change the stupid sign. So what does synthetic division do? It says, let's change the freaking sign right now, at the beginning. Do you guys get that? Change that every time. Change it. But this one says, let's not even make it minus 1, let's make it 1. Let's change the sign right now so it's always ready to go. So let's keep going here. 4, negative 6, negative 5, negative 5, 0. What's that good for? Yeah, it's no remainder, which means I factored it one step, right? How do I factor this now? I factored it as m minus 1 times m to the 4th plus 6m cubed plus 4m squared minus 6m minus 5. That's how I factored it. So what do you do now? Well, to be honest, I wouldn't normally write that there. I just wanted to put it there so you guys can see how to interpret the answer so far. I would just kind of keep going with synthetic right off of that. The last number is still 5, basically, right? So let's try to synthetically divide by 5. Now I'm trying to break up this chunk. I got that little rock, come plop it off, and I got the rest of this big old chunk to work with. Does this look like it's going to get somewhere? 1, 5, 11. I've lost faith. So maybe try negative 5. 1, negative 5. 1, ooh. You guys see how the synthetic has a built-in kind of bullshit detector? Well, that's bullshit. That ain't gonna work. Right, and you can quickly start over. Long division, good God. Multiply, add. Multiply, add. Multiply, add. Sweet. Yes?
So did you just choose one?
Because it's a multiple, it's a factor of 5.
Oh.
And now I'm using 5 because it's a factor of 5.
So
Negative
you're
5.
choosing them
Based on that last number.
Okay.
Because again, if this is going to factor as a series of binomials, then the last number has to be factorized amongst all the last bits of all those pieces. So that relates to all the ones you need to try. This is 176 stuff. This is rational roots. Yeah.
So in that negative 5, you skip the first one because negative 5 is going to 1?
No, I skipped the first one because the first number is independent of this. If you remember the long division, we thought about the m going into the m to the whatever power, and it was the coefficient of that I would write down. So if I had m minus 2 going into 3m squared minus who gives a shit, wouldn't it be 3m that I would write there?
Yes.
3. So the 3 would just come down because it's part of the answer. Of course, this is all assuming that I'm dividing by 1m plus b or something, you know, which is really what synthetic is built on. So then I can just keep going. We try to divide by 1. 1, 1, 2, 2, 1, 1, 0. Sweet. So what have we got so far? What pieces have I got so far? I've got m minus 1. Careful. M plus 5. M minus 1. And then right now I've got m squared plus 2m plus 1, which factors really nicely. So we get m equals 1, negative 5, negative 1, and these both are multiplicity 2. So now I can do the answer. I got a bunch of real roots. They're not repeated, but who gives a shit? The way. So how do you take care of these two ones? Be y equals c1 e to the x plus c2 e to the, what did I leave out? Here. c2 x e to the x. Now take care of the negative 5, c3 e to the negative 5x. Plus, and then I just do the same thing again with the negative ones. C, where am I at? 4 e to the negative x plus c5 x e to the negative x. Woo! What is it? Because when it's repeated roots, right? And we did this, good thing. We did that last time. We did it the long way, and then we said, doesn't matter what the number would be, it's always going to be the same way. Is that, do you guys? So, I mean, when you get to a higher level of math, sometimes it's really easy to say, well, all the other math doesn't matter with shit, but you know better than that. It at least goes back to trig, but now you're realizing it goes back further than that shit. And I know you got symbolic, calculators that'll tell you how to do this, but believe it or not, if you forget how to factor shit, that's what builds into other things. You have less of a connection to those things. Your foundation is shaky. That's why I worry about how much we're moving towards letting technology do all this shit for us. It's scary, man. Oh, it might just be. I'll be dead before everybody else dies from whatever happens to the world after this. I still feel bad. All right. So as an example of that's the highest order one that we've done. We've solved a fifth. Why was it relatively easy? Because the coefficients are all constants, and we have a way to attack that. Right? Homogeneous, linear, constant coefficients. A lot of restrictions means it should be easier than just some free range occurring in the wild differential equation. Okay. So last thing for today. Oh, okay. Let me see if I can work this one kind of backwards here. Let's see, why is that? And then, so y prime would be 6x plus 2, and y double prime would be 6. Cool. So then what is y double prime minus 3y prime plus 2y? Bless you. Gotta be a little careful, of course, with 9. So you get 6 minus 18x minus 6 plus 6x squared plus 4x minus 14. Right? That, of course, would be up here, right? So I get y double prime minus 3y prime plus 2y equals, let's see what we got, 6x squared minus 14x minus 14, right? Ooh. Now, but think about it. So if I'm given a problem like this to solve, let me see if you guys remember. What would the very is this? What kind of a DE is this? What kind of a DE is this that we've created? Tell me what you can.
Second order linear.
Ooh, well, channel. Second order, linear, non-homogeneous with constant coefficients still. Oh, shit. But the thing to realize is, now this is non-homogeneous, so who can remember with the very first step, when I'm asked to solve this, what do I do? Very first thing. We don't even know how to do this, but it doesn't matter, because what's the first step?
Check to see if it's unique and also continuous.
No. I appreciate that, though. But here, everything's continuous, beautiful. This is everywhere. I mean, this is, interval would be negative infinity to infinity, but I appreciate that. You do have to kind of look through and see if there's any trouble spots in general. But what is the first step to solve this?
Solve it as homogeneous.
Yes, look at the associated homogeneous equation. You got to find the y, the c's, right? The yc complementary stuff, because they are not going to screw with the yp's that we get. Remember that whole discussion? A part of the answer to this will be everything that makes it 0 plus whatever makes it this. Because the parts that make it 0 will not screw with this. That's a beautiful idea. So the first step is always, would be look at the associated homogeneous, right? But now the new step now is to then do the YP. We've been talking about the YCs like crazy, but now we're finally going to figure out what if it's not homogeneous. Can you imagine, is there any way that the answer to something, we know what the answer is, we started with it. But if I saw this, is there any way that the answer could be higher than a second degree? None of these are missing, right? Do you guess? I could have related these two to each other, and then, totally could have been. But I that's not what I did. And then there's ways to deal with if it's these two. Remember that? I don't know if you guys remember that. Maybe I should do a problem like that in a second. If all of these are there, then the answer's there's a specific look the answer has to have. And that's the basis of this next section. When you first get into this next section, you feel like you're cheating a little bit, because what the first step is, assume what the answer looks like. So it feels like you're cheating. But there are certain things that go here, and we have to talk about what those certain things are. There are certain functions here that I couldn't do that with. I couldn't. And that's why the next sections exist in chapter 4, are for those. But there's a whole table in this section of valid functions to try guessing for. Guess what the form looks like. And this is called undetermined coefficients, because what would the form of the answer have to be here? It would have to be ax squared plus bx plus c. So let's try this out. Let's first do let's do this exactly the way you would do it, as if I gave this problem to you. So let me write it over here like it's a problem. We already know the answer, which is awesome. Or you know the particular solution anyway. We have no idea what the complementary solutions are for the homogeneous, the associated homogeneous one. Where to go? So what is the associated homogeneous? It would just be y double prime minus 3y prime plus 2y equals 0. This is kind of funny how, I don't know if subconsciously I made this factorable or what, but and of course, what method do you use here for a homogeneous constant coefficient?
Set auxiliary.
Yeah, so what would the auxiliary equation be?
X squared minus 3m plus 2.
This is all old news, by the way. I want to make sure you understand. We've already done this shit. But this is a part of solving that. You want to find everything that makes it 0 and add it to the stuff that makes it that. And altogether, that's the complete solution to this. So, of course, how do you factor this? So you get m equals 2 and 1. So what's the complementary solution? Will be
1e to 2x.
yep, so 1 equals 2x plus c2e to the x. I love it. Distinct real roots. We love those. They kick ass. So the new stuff. Which was I've sort of kind of skirted around this idea before, but now we're going to directly do it. It's an official method, which is guess what the answer looks like. Based on certain, and obviously, hopefully, polynomials out of here are completely fine. There's a polynomial on this side. They have the most beautiful functions in the universe. You assume the answer is in a form equal to that, and you go to town. Now, there are going to be, hopefully you understand, there are going to be little bumps that are easily taken care of, thank God. But they can happen to anybody. But let's see what happens here. Let's go up. So we assume yp is, where do you go? Ax squared plus bx plus c. So then let's just say y there. We know it's yp, right? Find yp. Assume that answer looks like that, so then y prime is going to be 2ax plus b, and y double prime is just 2a. Is that cool? Now, I'm going to say a phrase right now that will make people cringe, but I want you to realize it's the best parts of this method that this is related to. This is going to be sort of like partial fractions. Oh, shit. Because in that case, you try to relate coefficients, right? So what do we get on this side? We get 2a minus 6ax minus 3b. Is that cool? Plus 2ax squared plus 2bx plus 2c equals 6x squared minus 14x minus 14. This isn't exactly busy work, it's really close to it, but this is where you should just, you can sink your teeth in this shit. Arrgh.
Where'd you get the left-hand side of that equation? 2a minus 6ax.
Oh. Y double prime minus 3y prime.
Oh.
Yeah,
Okay.
just plugging it in. And again, this is the part that would not exist here, right? I mean, I just wanted to start with a specific answer so we knew what to expect at the end. But it is sort of like what we did here. We're just doing it with the answer and we don't know what A, B, and C are. So we're really doing the exact same thing we do over there.
Because we're assuming it looks like that.
Exactly. So if your assumption is incorrect somewhere, so we have to be very careful with what the rules are, what you're allowed, what functions you're allowed to do this with. There's certain types of functions you're allowed to do this with. If you leave something out, then you're going to get some bogus answer. Somewhere it's going to say 7 equals 28. You're going to be like, that's weird. But it's going to try to tell you something went wrong. What do we get here? We get 2ax squared. Let's see. Minus 6ax plus 2bx. So I get plus 2x. Do I really want to do that? No. We'll just leave it like that. Plus 2b minus 6ax plus 2a minus 3b plus 2c equals this business. Whoa. So now you just equate coefficients, figure out what A, B, and C are. You guys see what's happening? So now 2a has to equal 6. So A is 3, which is really nice. 2b minus 6 times 3 has to equal negative 14. So 2b has to equal minus 18 plus 8, so 4. So b is 2. A is 3. B is 2. So far it looks good. You guys with me on this? This type of thing? You've done this kind of thing before. In order for this equality to be true, all the coefficients of x squares have to be equal to each other. All the coefficients of x has to be equal to each other. And then finally, so now we know A is 3, B is 2. So 2 times A minus 3 times B plus 2C has to equal negative 14. So 6 minus 6, so 2C is 14, negative 14, so C is negative 7. Thank God. You got it. So what is the complete solution? It'll be y equals, I don't even know if you're still going. YC was here, C1e to the 2x plus C2e to the x plus YP, which is now 3x squared plus 2x minus 7, which is what we started with over there, of course, right? So if I throw this in, it makes it come out to be 6x squared minus 14 minus x minus 14. If I throw this in, it's plus 0, because that's the one that makes it 0. So of course it's the same stupid answer. So that's why this whole thing is the solution. So on page, just to give you something to look at, page 143 is an example list of the types of functions you can use this on. It actually shows you what you would see in the differential equation and the form of the answer you would guess it to be. So I remember as a student, and I know my experience might not mimic yours entirely, but this is the one that sticks out in my brain because this is the one you actually use very often. There's a lot of functions that happen in the real world, in situations, engineering, physics, whatever. They are these nice functions. They are these functions you can use this approach with. So it happens a lot. Or if it's a more disgusting problem, this is the first step, and then you use perturbation theory, whatever the hell you got to do after that. So this happens a lot. This is why this is the thing I remember the most, because I use this all the damn time. Okay, I think that's enough for tonight. What do you think? That was section 4.4. To be honest, I'm thinking about making 4.5 extra credit and just talking about a couple things out of there. Because the results of 4.5 are the same as the results of 4.4. They just use a different approach. So there are a couple things I want to talk about that approach. But I'll make the homework extra credit. So we can get into 4.6 next time. Don't forget, quiz first thing Wednesday.